Hello everyone, so this is my first math video and it's going to be on the topic of definite integration. So let's just go through some properties first right away. Let's define g of x is equal to integral from a to x f of t dt. Now if f is continuous on closed intervals a comma b and differentiable on open interval a comma b, then g dash of x is equal to f of x. That is the first fundamental theorem of calculus. The second theorem states that if you have an integral from a to b f of x dx, that is just basically equal to f of b minus f of a, and this is the fundamental theorem of calculus second, and where f is just basically the antiderivative of f such that f dash is equal to f. Now let's go through some properties right now. 1 second. So there are almost like 6 properties to go through. The first property is such that integral of a to b of f of x dx is equal to integral of a to b f of t dt. This can be proved by putting a substitution where t is equal to x, so therefore dt is equal to dx, and therefore this comes into the integral. B, you have an integral of a to b f of x dx is equal to minus of b to a f of x dx. This can be proved by putting a variable such that x is equal to minus u and dx is equal to minus du, and then you can use property 1 to arrive back at this. Now the third property is you can split the integral, because integration is just basically summation of the area, so you can just split the graphs into multiple continuous graphs and then add them up. So a to b of f of x dx is equal to integral of a to c f of x dx plus c to b f of x ds, where c may lie inside or outside the closed interval a comma b. Now the next property is integral from minus a to a f of x dx is equal to integral of 0 to a f of x plus f of minus x the whole bracket dx. This can be broken up into 2. It equals to 0 when f of x is an odd function, and it breaks up into 2 integral of 0 to a f of x dx when f of x is even. So these are the properties you must remember when solving definite integration. The next property is the most important one, or they say as a king's rule. Integral of a to b f of x dx is equal to integral of a to b f of a plus b minus x dx. Now if a is equal to 0, then it becomes integral of 0 to b f of b minus x dx. So these properties you must remember when solving definite integration. Now let us go and solve some problems right at the start. So the first problem we will be solving is, let's name I is equal to integral of minus pi to pi x sine x by e raised to x plus 1 dx. Now wherever you see an integral in the form of minus a to a, you always apply the property such that minus x first, that is pi plus minus pi minus x. So you could check over here, it will be minus x over here, so this would come on top and this will become minus. Sine is an odd function, x is also an odd function, so here this becomes positive. So let's apply the property. So the new I is equal to integral of minus pi to pi minus pi minus x sine of pi minus x whole divided by e raised to pi minus x plus 1, which basically I simplifies into minus pi to pi x sine x by e raised to minus x plus 1, which is just basically equal to x sine x into e raised to x by 1 plus e raised to x, integral of minus pi to pi dx. So this call it 2 and this call it 1. Now what I'm going to do is I'm going to add up 1 and 2. I'm going to add up 1 plus 2, which basically implies 2i, because they both are the same integral according to King's rule, f of minus pi. Now as you can see in 1 and 2, x sine x is common, so I'm taking x sine x common and writing as e raised to x plus 1 by e raised to x plus 1 dx. As you can see, these two clearly cancel out, and then basically it's just solving integration by parts. I'm gonna use the di method, so follow me if you can. Two I is equal to minus pi to pi x sine x dx. So differentiation, integration, x sine x, differentiation of x is 1, sine x is minus cos x, cross multiply means 2i is equal to minus cos x into x pi to minus pi plus integral of cos x dx pi to pi. Now you can apply the limits. Minus cos x, so here imagine if you're applying pi, so let's take minus common outside. Cos pi is minus 1, so minus pi minus of minus pi in terms of cos side. Cos is an even function, so basically becomes minus 1 plus minus pi plus sine x raised to pi minus pi, which is basically equal to 2 pi, as this cancel out to be 0, is equal to 2i. So therefore I is equal to pi. So therefore the answer of the integral is I is equal to pi. Let's take one more in J problem. So the question is, suppose I of m is equal to integral of 1 to x log x raised to m dx satisfies the relation Im is equal to k minus L into integral I of m minus 1. We have to find out what k and L equal to. The options are A, k equal to e, b, L equal to m, c, k equal to 1 by e, and d, none of these. So you could pause the video right now and try to solve it on your own. Now the solution to this problem would be again integration by parts. So let's apply integration by parts. Integral of 1 to x log of x raised to m ds. Now what I'm going to do is, once again, I'm letting d and I. Now I'm going to be integrating 1, which is x. I'm going to be differentiating log x raised to m. The differentiation of log x raised to m is equal to m into log of x raised to m minus 1 into 1 by x according to chain rule. Now what I'm going to do is cross multiply. So I is equal to x into log of x raised to m into x by 1 minus 1 by x into x cancel out, integral of m into log of x into m minus 1 dx. Applying the limits over here, x remains the same, log 1 0 undefined, 0 raised to m, 0 0 anything raised to m, and then so it just basically becomes I is equal to x into log of x raised to m minus m into I of m minus 1. So from the question we can see they have given I of m comparison is equal to k in minus L of I m minus 1. So L is equal to m and k is equal to x into log of x raised to m. So the correct option is option B. So these are two questions which are done for this video. I hope you liked it. Please subscribe and share it.